Lesson 12.1, Adjacent and Vertical Angles. So in this first lesson of Chapter 12, our goal is to understand the geometry and vocabulary involved with angles. All right, so a lot of this is just going to be a lot of vocabulary terms, and we're going to also do a little bit of math based on what those terms can tell us about the different problems. All right, so first off, some vocabulary that you might already be familiar with, but it would be good to have in your notes. So when we have just a single angle, we tend to classify them by how many degrees that angle measures. So we have these four. Acute, which is an angle that is less than 90 degrees. So right here, this looks like maybe 30, 40 degrees. But anything less than 90 is an acute angle. Now a right angle is exactly equal to 90 degrees. And to denote that, we sometimes use this little symbol right here. It's just a little square right in the corner to say that's a perfect right angle. And then obtuse is anything larger than 90 degrees, but at the same time less than 180. And then finally, we don't even, you almost might not even think of it as an angle, but we call this a straight angle because it's been opened so wide that the two arrows form a perfectly straight line, which is equal to 180 degrees. So acute, right, obtuse, and straight. All right, now for this next part, what if we start looking at angles in combination? So for this first one, what I always like to think about is when you make a pizza and then you slice it up with one of those cutting rollers. I actually used to work in a pizza place, used to do this all the time, so I guess that's why this sticks with me so much. So if you think about the first two cuts, if I slice a pizza, and I try to cut it down the middle, it's not going to be perfect, but something like that, and then you make your second cut, you get at least two slices cut with the rest is still needing to be cut. But I'm going to leave it like this because what I want to point out to you is specifically this angle right here and this angle right here. Now these are called vertical angles because when I cut this first angle, I ended up creating a second angle which is directly across from the original. Now the other thing that's interesting to note that if you think about it, that since these were cut at the same time, they're mirror images of each other. And so that not only means that they're vertical angles and they're directly across from each other, but that these vertical angles must be congruent. That the size of this angle right here, in terms of degrees, is the exact same angle here. And so this is another term we want to add in, and sorry about the blurriness of this. The cut and paste wasn't high resolution. So two angles are vertical angles when they are opposite angles formed by the intersection of two lines. In other words, they're that mirror image that I was talking about earlier. And so not only are they vertical angles then, but that also says then that they must be congruent angles. They have the same measure. So as a visual example of this, here you've got a similar situation but minus the pizza. Angle 1 and angle 3 are vertical angles because they're directly across from each other and they're mirror images. And notice how they're labeled. They put this little arc in here to say angle 1 is the same as angle 3. Another set of vertical angles here, we've got angle 2 and angle 4. And so to keep those different from 1 and 3, but to show that 4 and 2 are the same angle, notice how they've put two arc lines through to denote those measurements. Okay, so I can guarantee that angle 1 is congruent to angle 3 and angle 2 is congruent to angle 4 because they're vertical angles. Now, one other thing, and this is more, again, just vocabulary. We also have something called adjacent angles. So two angles are adjacent angles when they share a common side and have the same vertex. In other words, adjacent is a fancy way to say they're next to each other. So if I were to go in here and mark these, so what they're saying is that angle 1, which I'll label like that, is adjacent to angle 2, and I'm going to label it differently. Okay, they share a side in common, and they share this common vertex in the middle here. But basically the way I like to think of it in layman's terms is that these two angles are just next to each other. Okay, 2 and 4 are not adjacent. 2 is across from 4. They share the same vertex, but they don't share a side. They're not next to each other, so they're not adjacent angles. In fact, 2 and 4 are vertical. So think about what another pair of adjacent angles would be. Maybe you picked 3 and 4, or maybe you picked 1 and 4. But anywhere where they're attached at the same vertex and they share a side. Again, the easy way to think about it is they're just next to each other. All right, so let's try out a problem that helps us identify adjacent angles. So here's a problem. Name 2 pairs of adjacent angles and 2 pairs of vertical angles. Now, as far as adjacent angles go, there are several choices here. I'm just going to pick a few. So let's say I choose this one right here. This angle on the top. So that would be this angle. VWX. Now notice, if we hadn't already covered this, notice how these are listed. That I started here, V, then to W, then to X. I could have labeled this same angle X, W, V, but I do it in that order. I pretend I'm actually drawing the angle, and so I list the letters in that order. Specifically, the one that's at the vertex in the middle here, that's the one that has to be in the middle of your listing over here. Alright, so now as far as adjacent angles, well, this angle, we could either say it's adjacent to this one or this one. I'm just going to choose this one as my adjacent angle. So there's 2 pairs of adjacent angles. VWX, and then VWZ. Alright, they wanted 2 pairs, so let's do another pair. How about this one? Here we've got XWY, which would be this one, XWY. That'd be this angle on this side, right in here. And so an adjacent angle would be either up here, because they share this side, or this angle down here. So let's say I choose the bottom one. So that would be angle YWZ. YWZ. So that'd be this angle, makes these 2 listed as the adjacent ones. Alright, now let's go back to vertical. Vertical's a little different. I'll put those down over here. In fact, I should probably put an arrow here so we don't get confused. So adjacent angles are these 2. So vertical angles, let's put them down here. So I might start off with this one, VWZ. So VWZ is this angle over here. And so vertical, here I don't have a choice. Vertical is very specific. I'm looking for that mirror image angle, which is directly across. So it's this one on this side. So that's going to be this one, XWY. Alright, and let's pick one more to show as an example. Let's say we're doing this angle, YWZ, which would be YWZ, that'd be this angle down here. Well, the mirror image directly across from it, the vertical angle, would be this one, VWX. Alright, so that's adjacent angles and vertical angles. Alright, so let's take a look how we might actually do some figuring out here. Let's combine algebra and geometry in these next couple examples. Alright, so here's a problem similar to the work you might do. Find the missing angle. So here I've got a picture of 2 intersecting lines. One angle 70 degrees, the other angle's x. Our job is to figure out what x is based on some of the information we just learned. Now in this case, I'm hoping you see it just from the fact we were just talking about it a second ago, is that this angle and this angle are vertical angles. So that means that if they're vertical angles, they're mirror images of each other. So this angle is the same as this one, which means they're also congruent. So basically from this I can just put my answer, which, well, it must be 70 degrees. Okay, because if they're vertical angles, they're congruent angles, which means they have the same measurement. Let's take another look at another one. Here's another one where you might do some mathematics. I'll put it down here. Now here this involves a couple things. So here we need to find this missing angle down here. We have this smaller angle, and we also have the fact that the 2 angles add up to 90 degrees. So this is a right angle, and these two angles are adjacent. So how would I go about figuring this out in implementing some algebra? Okay, well, it might look like this. We know that the two angles together add up to 90 degrees. So if I take the one angle, which is 31 degrees, and add it to my mystery angle here, which is labeled as x plus 4, I get an equation I can solve. Some of you, in fact, might remember this as complementary angles, any two angles that add up to 90 degrees. So if I simplify this, 31 plus 4, that's 35. Recopy the x. And then solve for x by undoing plus 35. What I do to one side, I do it to the other. So x equals 55 degrees. Okay, which is not our answer. They wanted the missing angle. That's just what x is. So don't forget to go back here. We're looking for this angle, which is x plus 4. Well, if this is x, x plus 4 would actually be 59 degrees. Okay, so be careful about that. We're not always solving for the unknown here like we're doing in equations. That unknown is part of a larger problem which we need to plug back in. Alright, so in this lesson, again, a lot of vocabulary, a little bit about some mathematics and what we can do with that information, but basically have this in your notes and get to work on the classwork.